looking at these problems on page 16 of the 6.4 slides. Our first problem is to compute and interpret the results of A, C44, and B, C42. So remember that we're looking at the number of combinations of 4 items taken 4 at a time, and we'll use our combination formula, which is CNR equals n factorial over r factorial times n minus r factorial. So here, we're asked to find C44. Okay, so that's going to be, 4 factorial over 4 factorial times 4 minus 4 factorial, which is 4 factorial over 4 factorial times 0 factorial, which gives us 4 factorial over 4 factorial times 1, because 0 factorial is 1. So in other words, this is 1. Because we've got 4 factorial over 4 factorial, and anything divided by itself is, of course, 1, except for 0, and we're not worrying about that right now. On the other hand, if we want to find C42, that's going to be 4 factorial over 2 factorial times 4 minus 2 factorial is 2 factorial again. So that's 4 times 3 over 2 times 2, times 2 factorial over 2 times 2 is 2 factorial, so that's just 2 times 2. Well, I can cancel one of those, I can cancel a 2 from the 4, and that's 6. Next up, we're asked to find a Senate investigation subcommittee of 4 members is to be selected from a Senate committee of 10 members. Determine the number of ways in which this can be done. Well, here the order doesn't matter. We're just picking 4 members of the committee to serve on the subcommittee. So we're going to use our combinations formula again. That gives us C of 10, choose 10, 4. I keep wanting to say 10, choose 4, because that's another way that this is often used, and it's certainly the way that I was taught, but the terminology in the book is a little different, so we're going with their stuff. So this is the number of combinations of 10 people taken 4 at a time. That's 10 factorial over 4 factorial times 10 minus 4 is 6 factorial. So I can write that as 10 times 9 times 8 times 7 times 6 factorial over 6 factorial. I'll cancel both of those times 4 times 3 times 2. Well, 4 times 2 is 8, so I can get rid of that right away, and then I'll get rid of one of the 3's in the 9, which leaves us with 10 times 3 times 7, which is 210 ways to establish a subcommittee of 4 people from a Senate committee of 10 people. Back to the PDF. Our next question is, how many poker hands of 5 cards can be dealt from a standard deck of 52 cards? And this is really no harder than the last 2 problems. We're just dealing with bigger numbers. So what we're doing here is we've got 52 cards to choose from, and we're choosing 5 of them. So this is C52, 5. And that gives us 52 factorial over 5 factorial times 52 minus 5 factorial, or 47 factorial. So that's 52 times 51 times 50 times 49 times 48 times 47 factorial, over 47 factorial times 5 times 4 times 3 times 2 times 1. I cancel that out. Our 1, we don't have to worry about that. We can get rid of that right away. We've got a 5 in our 50, which leaves us with 10 there. We've got 4, 3, and 2. 4 times 3 times 2 is 24. So we can divide 48 by 24 to get 2. Okay, so we're left with 52 times 51 times 10 times 49 times 2. And when we run that through a calculator, 52 times 51 times 10 times 49 times 2 is 254,800. That is the total. The book disagrees with me, which means I did something wrong. Let's see, where did I mess up? One moment here, sorry. 52 times 51 times 50. Yeah, that's I must have entered a number wrong. Let's see here. Times 49 times 48 divided by 5 times 3, 120. Yeah. Okay, so I probably just entered my numbers wrong. It's 5 times 24 is 120. I just entered something wrong. This is fine. Yeah, I just did my math wrong in the calculator. I use an iPhone for most of this, and iPhones are very sensitive, and I don't always notice when I touch the numbers incorrectly. So it's 2,598,960. Sorry about that. That is the number of poker hands that can be drawn from a deck of 52 cards. Last problem on this page. The members of a string quartet consisting of 2 violinists, a violist, and a cellist are to be selected from a group of 6 violinists, 3 violists, and 2 cellists. In how many ways can the string quartet be formed? And in how many ways can the string quartet be formed if one of the violinists is to be designated as the first violinist and the other is to be designated as the second violinist? Well, in this case, in A, this is pretty simple. Give me 1 second, sorry. Okay, so in A, we've got 6 violinists and 3 violists and 2 cellists. So if it doesn't matter the order in which we are going to pick our violins, this is going to be C of 6, 2 times, I'm going to pick 1 violist and 1 cellist, so that's just 3 times 2. We could write it as C of 3, 1 and C of 2, 1, but those are 3 and 2 respectively, so we don't need to bother. But C of 6, 2, that's 6 factorial over 2 factorial times 4 factorial, which is 6 times 5 divided by 2, and that times 3 times 2, times 3 times 2. So that's 15 times 6, which is 90. On the other hand, if the order does matter, then this isn't, in fact, C of 6, 2, it's P of 6, 2. Because if the order matters, then we have different, then it does matter whether we pick one, the arrangement matters, the order matters. So we're going to go with p16 here, times 3 times 2. And that's just going to be 6 factorial over 4 factorial. Okay, times 3 times 2. Okay, well, that's going to be 6 factorial over 4 factorial is 6 times 5 times 3 times 2, or 30 times 6, which is 180. All right, that is it for this set of problems. If you have any questions, please get in touch.